valued viewers. I hope you are all doing very well. Today's featured video is Union Pacific before the big boy, the 9000 class. Enjoy. So our story begins in the 1920s, and that's when railroads began seeking ways to move heavy loads at a much greater rate of speed. And up until that time, many companies used Malleys, which were the first articulated type of locomotives, and were also known for their power, but often had top speeds of little more than 20 miles an hour at best. And furthermore, the early articulated locomotives such as the Malleys had problems with stability at higher speeds, and so locomotive builders sought to increase power and speed by building three-cylinder locomotives on a rigid frame. Now, at that point in time, the idea of using three-cylinder locomotives was not a new one. However, locomotives had been steadily increasing in size to a point that they could no longer grow in size due to the forces exerted by the larger cylinders required. And of course, the larger cylinder that you're using, you increase the risk of breaking or cracking the frames. In the early 1920s, the idea of using three cylinders came to the front of U.S. builders' minds. One of the advantages of three-cylinder power is a more even distribution of cylinder thrust. With a standard two-cylinder locomotive, there are 4 power pulses per revolution of the bogies, and with a three-cylinder locomotive, you get 6 pulses per revolution. The reduced rail pounding, wheel slipping in general provided a more smooth ride to these locomotives, as the running gear and bogies seemed to be more balanced. So once again, we're in the 1920s, and Union Pacific and Southern Pacific approached Alco with the idea of building a high-speed freight locomotive. Until that time, the 210-2 wheel-arranged locomotives for both the Union Pacific and especially the Southern Pacific were their main high-speed freight locomotives. The idea was to increase the size and power of this design by transforming it into a three-cylinder locomotive. The third cylinder for this locomotive was located between the frame and was connected to a cranked axle on the second set of driver wheels. And also, this third cylinder was set at an 8-degree inclination that allowed the main rod and crosshead of the third cylinder to clear the axle on the first set of drivers. And it was decided that the best way to operate the valve gear for the third cylinder was to use the Gresley valve gear, which was invented by the British locomotive builder Niall H. Gresley. This valve gear consisted of 2 rocker arms that were attached to the extending valve stems of the outside cylinders and sat on the front of the locomotive. The inverse sum of the motion of the 2 outside cylinders created the proper motion for the valve of the third cylinder. The additional weight of the Gresley valve gear on the front of the locomotive necessitated a 4-wheel leading truck, and the results of these designs were a locomotive with a 4-10-2 wheel arrangement. The Union Pacific ordered one for testing, and it was given the road number 8000. Imagine that, a major U.S. railroad that orders one prototype for testing instead of a fleet of 30 right from the get-go. So the number 8000 test locomotive was delivered to the Union Pacific in 1925, and it underwent extensive testing, and then it was quickly determined by the Union Pacific Design Department that in order to take a full advantage of the three-cylinder design, an even bigger locomotive would be required. The designers at the Union Pacific quickly began working day and night, working in conjunction with the builders at Alco to come up with a new design based on data collected from the number 8000. The idea was to add one more axle or set of drivers, and the results of these discussions and design was then the 4-12-2 locomotive wheel arrangement. So then this new wheel arrangement of 4-12-2 were given road numbers starting with 9000. And it's believed that 9000 was used because there were 9 wheels on each side of the locomotive, and the locos were often referred to as the Nines. So the 9000 itself was delivered in April of 1926, and after only a few months of designing and a mere 4 months on the erecting floor. The locomotive immediately began testing, and it became apparent that the loco could do everything it was designed to do, and the Union Pacific took a liking to this locomotive as it represented big power. One thing the Union Pacific always prided itself on, and the company bought 87 more locomotives of this type over the next 4 years. Later, this design became known as the Union Pacific type, as it was the only company to use this wheel arrangement. And it didn't take long for the Union Pacific to start replacing the 2880 Malleys with these 9000s. These new 9000s 4-12-2s could pull 100 to 125 freight cars that were previously pulled by the Malleys at speed of 50 miles an hour or better that can do it 80% more efficiently. These locomotives were the main workhorses over the Union Pacific mainline from Cheyenne to Ogden until the debut of the Challengers and the Big Boys. The 88 total locomotives of the 412-2s owned by the Union Pacific were all built by Alco in Schenectady, New York, and were delivered in 5 separate orders from 1926 to 1930. The first order, UP1, consisted of 1 locomotive, the 9000. The second order, UP2, consisted of locomotives 9001 to 9014, all delivered in 1926. Union Pacific 3 consisted of locomotives 9015 and 9029, and numbers 9700 to 9707, which were delivered in June and July of 1928. The 8 locomotives numbered 9700 to 9707 were ordered for the Union Pacific subsidiary Oregon Washington Railroad and Navigation Company and were used on this branch until 1929. At that time, they were resold back to the Union Pacific and then renumbered to 9015 through 9062. The fourth order for the Union Pacific consisted of numbers 9030 to 9054 and were delivered from June through October of 1929. And the final order was for numbers 9063 through 9087, and these locomotives were delivered in July and August of 1930. It should also be noted that on 8 of the 9000 class locomotives, there was a change from Gresley valve gears to Walshert valve gears, which was known as the third link modification, and then the cross-compound air compressors were moved from the front of the smoke box to the sides of the locomotive. Now this revision had nothing to do with adding of the third link, but was done to make the maintenance on the pumps much easier as they were now more accessible. The removal of the pumps from the front of the locomotive drastically changed the appearance of the locomotives, and these locomotives that were modified were quickly nicknamed the Boldface 9. And also, only 8 of these locomotives were converted to such because after the first 2 orders from the Union Pacific, which covers those 8 locomotives, Timken roller bearings were added to the Gresley valve gears, which solved pretty much this problem. So any 9000 series locomotive produced after the first 2 orders had these Timken roller bearings in the Gresley valve gears. And also very noteworthy, the 9000 class locomotives had the longest rigid wheelbase in North America, and it was the longest in the world until the Soviet Union built their AA-20 414 4-wheel arrangement locomotives in 1934. The trailing truck carried the same axle load as the drivers, which was unusual. And with that, the following specifications apply to the Union Pacific's 4-12-2 wheel arrangement 9000 series, also known as the Union Pacific class. 88 total locomotives were built by the American Locomotive Company between the years of 1926 and 1930. The main driver size was 67 inches, the length of the locomotive was 102 feet 7 inches, the axle load of the locomotive was 59,000 pounds, the adhesive weight over the drivers was 354,000 pounds, the locomotive weight was 496,500 pounds, the tender weight was 310,599 pounds, a combined total weight of 807,099 pounds, the fuel type was coal, the fuel capacity was 42,000 pounds. The water capacity was 18,000 US gallons. The firebox grade area was 108.25 square feet. The boiler diameter was 92 inches. The boiler pressure was 220 psi. The overall firebox area was 591 square feet. The overall heating area was 2,560 square feet. The cylinders were 3, 2 on the outside and 1 on the inside. The cylinder size on the outside were 2 at 27 inches by 32 inches, and the inside cylinder was 27 inches by 31 inches. The valve gear were greasily conjugated, and with some modifications on the first 8 locomotives were Walshert, were rolling bearings. The maximum speed was 50 miles an hour. The tractive effort was 96,646 pounds. The factor of adhesion was 3.66, which was very iffy in terms of performance. And the railroad designation was UP1 through UP5. The numbers were 9,000 through 9,087. And they began retirement in 1953 through 1956. There's only one preserved, which is the number 9,000 itself. And that is located at the Rail Giants Train Museum. And the museum is located in Fairplex, Pomona, California. And with that, I'll wrap up the video, and I shall thank you for watching the video. If you enjoyed the content today, please hit the like button. And also, if you've not subscribed, please hit the subscribe button, as both features help the channel grow immensely. And if you would like to support the channel, you can do so by hitting the super thanks button, which is located next to the like button. And if you don't want to do it that way and want to support the channel in another way, you can visit our print shop at Nickel Plate Limited on Etsy.com. And we thank you once again.